Now let's discuss the fourth type of solution of radical equations. Now see this. The fourth type of radical equation we'll discuss is one the in which one side of the equation has radical equations, and basically it will be all radical signs, and underneath the radical signs you'll have quadratic expressions. And on the other hand of the equation, you'll have a linear expression and no radical sign. So how will we go about this? Well, you'll give this first radical expression the value of a, and you'll give the second radical expression the value of b. Now, as you know, this is a minus b. This can be written down as a minus b, and that is equal to this x minus 4, and we'll call this equation 1. Now we know this is a very basic algebraic expression, an algebraic formula, if you will, and it basically says that a square minus b square is equal to bracket open a plus b bracket close bracket open a minus b bracket close. So since we know this, now what have we done here? We've used this equation and we've applied it on our original question. So as you know, this is a, so this is now a square, and this is b square. So a square minus b square is equal to a plus b, and we know that x minus 4 is equal to a minus b over here. So this is a plus b into x minus 4. So now what you'll do is you can cancel out these radical signs as they're being squared, and then you get this. Now once you solve this, you get x squared minus 16, and again you'll use this particular expression here, this formula, and you'll apply it here. So x squared minus 16 can be written down as x plus 4 into x minus 4. So now, as you know, these x minus 4 terms can be cancelled out. So a plus b is equal to x plus 4, and this is now equation 2. So what you'll do here is, since we know that a minus b is equal to x minus 4, that is equation 1. So, and we have equation 2 is a plus b is equal to x plus 4. We can cancel minus b and plus b, and we can cancel minus 4 and plus 4. And you can add up these two a's and these two x's, and you'll get 2a is equal to 2x, and that means a is equal to x. So now this quadratic term that we had originally, that was equal to x, as you remember. See this? We know that a is equal to x, so you'll use this equation here. So you'll square on both sides. This radical sign will be cancelled out, and so you'll get a quadratic equation. And by using the quadratic formula, because obviously over here it is quite difficult, actually it is not even possible to do factorization, so you get this. You get two values for this. X is equal to minus 7 plus under root 17 over 8, and minus 7 minus under root 17 over 8. So now you check for extraneous roots. Well, over here it is, you can actually find the extraneous roots by using the values of x that you found and putting them directly in the equation given in the question. But it's much easier if you actually use this particular expression that you found earlier over here. You need to check if this is actually equal to 0 if you apply the values of x you found. So when you do this over here, this indeed gives you 0. So we know that this term is equal to 0. And now, wherever you find this term in the original equation, you'll put 0 in its place. So this will now become 0. And this, if you just write it down like this particular part becomes 0 as well. So this is now x squared plus 0 over here. And this can be written down as 0 plus 16 because over here you replace the quadratic expression with this term here. So now this becomes, as you know, this becomes x squared and these two will cancel out, and this is just basic under root 16, and so you get x minus 4 is equal to x minus 4. So this is indeed true. And if you use the same method for the other value that you found for x, you'll find that it is not an extraneous root as well. So these are both values of x. So the solution set is indeed this. There are no extraneous roots.